Hey, hello everyone, and welcome to our session for highway design, or our last few sessions for highway design. We talked first about horizontal curves, and today we're going to talk about vertical curves. Vertical curves has two components: the design, where we figure out what's your L minimum, and your L design, which is based on your L minimum, where you kind of approximate your L minimum or upgrade your L minimum to become your L design. And the second part is the surveying part, where you want to set up locations or stations of your vertical curve. We defined two types of curves. We defined crest curves or sag curves. Also, we have defined also two cases for each of this design, meaning that when you calculate, we started with crest curves, and we defined here two different ways of calculating, or not different ways, two set of equations based on some assumptions where we design our crest curves. And let me remind you of that. So the crest curve, you have either one of two cases. You're going to assume one of them. The first one is when you have a big curve. So when you figure out the problem of side distance, and this is one main issue for this kind of curve, because the pavement always hides something behind. So when the problem of side distance is really smaller than the length of the curve, or in other words, this is what you can see, and this is the length of the curve. So our assumption, we're going to assume always, or we start by assuming that you have a big curve, or in other words, L is greater than S. In this case, the set of equations turn to be as following: L minimum equals A S squared divided by 200 times the square root, or the open parentheses, h1 plus square root h2 squared. Let's define these values. So first of all, S here is the side distance, and that's the side distance. And we're going to make an assumption here, if you remember, that your SSD, which you calculate here from your equation of stopping side distance, to be equal to S, and that's an assumption. What do you mean by this assumption? The distance where you can see is going to be equal to the distance where you can stop. Again, stopping here is two distances when you react and hit the brakes. So we're going to assume that this is what you can see for a safe design. So that's S. A here, if you remember, is the absolute difference between the two grades. This is grade number 1, which is the tangent, first tangent, G1, and this is G2, which is the second tangent, G2, and this is G2 minus G1. Guys, when you see here either this G, in our example, most of the textbooks, when you see this G in uppercase, or when you see in the equation like some big number here, strange number with hundreds in it, 2 zeros, then just know that this equation took into account that we don't care about the percentage. So for 6%, you just take here 6. So G1 here is 6, and this one is 4, and so on. So again, when you find the equation, a big number here, or when you find here an uppercase G, then go directly and put the number as a number, a whole number, not a percentage. What's H1 and H2? H1, again, we assume that the height of the driver's eye, where he can see at night the headlight of the car ahead of him, and that's the critical case. So H2 assumes, gives you an assumption here that this is 3.5 feet. And again, it's critical for a short car or a small car where the driver's eye is really low, and that's the critical case. And H2 is the height of the headlight or the backlight of the car ahead of you, and H2 assumes it as 2 feet. If H2 values are used, this equation turns become very easy. It's going to equal AS squared divided by 2158. And that is the first case. Once you have an example of design, you start doing this assumption. So here, assuming your length of curve is greater than S. And then once you finish, you have now your L minimum and your S. Is your assumption right? Is it greater? If yes, you're good. You're good to go. You just go ahead and kind of find the value for your L design and round it up for your L design. Or go ahead and do the second kind of assumption when L is a small curve. What do you mean by small curve? The one I put here. Sorry, this is the big curve. Small curve is that like something like this. You have a very small curve here where the side distance issue happens on the sides of the curve. You have a big S and a small curve. This is what you can see here on the other side. So here, L is smaller than S. And you go ahead and go to the second set of equations here, and the LS, sorry, not LS, L minimum equals 2S minus, again, the 200, again, the H1 under the square root, H2 under the square root, square divided by A. So you see, it's just the same values, but it's just set up differently. And again, if you use the H2 default of 3.5 and 2, it's going to be equal to S minus 2158 divided by A. If this assumption went wrong, then you have to go this, then you're going to find once you compare it that always L will be smaller than S in this case. And now you were able to design. One other thing you have to note is that always the PVI, which is the point of intersection here, is going to be in the middle of the length of the curve. So that's the length of the curve. So you add up, subtract L over 2, add up L over 2 to find your 2 points here, PVC and PVT. Again, same here, your PVI is always in the middle. And you go ahead and you subtract L over 2 to find your PVC, and you add L over 2 to find the PVT. Now let's just jump into my presentation, and I apologize for my really bad handwriting, and let's go and set out for sag curves. Sag curves is a little bit different, and let's see what happens in sag curves. So these are the equations for the crest curves, and we're going to solve the question in separate video, or we'll do numerical examples. Before we go to sag curves, H2 always tries to help us with tables and charts that will take care of this set of equations. And this is for a specific case here for a big curve. And well, you remember the big curve when H2 defaults were used, and we came here with AS squared divided by 2158. What they did is that they stick this constant here, S squared divided by 2158, which is dependent only on the stopping side distance or the speed. And it's multiplied by A. A is different from one curve to another. A is different from one curve to another, so if you know G1 and G2, you calculate A, and then you can get this K from H2. We have here a table from H2, it's table 372 in the H2 manual. We have two types, metric or US customary. All you have to do, figure out what's your design speed, and directly using again the H2 default, it's going to calculate the stopping side distance. And then you have here the value of K. We have two Ks, and you notice here we rounded up to get the design K. So K here is, again, S squared divided by 2158, depending on this value here. And all you have to do is get your K multiplied by A, and again L. But one test you always to test again, is that once you get your K, you want to make sure, based on the G1 and G2 that you have, is that L is greater than S, a big curve. If this is not the case, then you have to go to the other assumption. Now let's move now, guys, to SAC curves. SAC curves has a different criteria. What do you mean by different criteria? First of all, when you drive in the morning, SAC curves are amazing. Why? Because you can see away from one side to another, except for one specific case when you have a bridge above. This is where truck drivers have issues of seeing from the other side. So what about SAC curves? That side distance is the problem. The problem is the following. When you drive at night, and let's not talk about backlights now, we're talking about a deer hiding in the dark. I have here a deer hiding in the dark. And what makes you see the deer is your headlights. So what happens here is that you have a car, you're driving, this is the height of your headlights, and this is the angle of your headlights, and this is where you suddenly can see the tree or the deer hiding in the dark. And that's the only critical case of your sight distance. So again, the sight distance is provided by the headlight. So let me go down here. So the sight distance you can see here is defined by number 1, h, which is the height of your headlights. And number 2, what you can see here on the pavement is your object here that you have to stop once you see it, for a deer, for example. And the beta, which is an angle, how your headlights go up. So again, it depends on your low headlight. It's about 1 degree above. So again, to see, and this is what you can see. It's based on what your headlights can show you. So AASHTO gives us again some kind of default. 2 feet, which again, when you have any lights above the pavement, it's going to be 2 feet. And this beta angle is 1 degree. It's a very, very small angle because you don't want to hit the eyes of the car coming in front of you. But the SAC curve, since sight distance is not that critical, then not only sight distance provided by headlight is the critical one. Sometimes we have the 3 things we discussed when we talked about vertical curves in general. SAC curves are very bumpy. They are very, very small, meaning that you go like this. If this is small, it's going to be a bumpy ride. You want it to be big. So comfort is one important thing. Another thing, you don't want your SAC curve to turn into a swimming pool. So drainage is another important issue here. Finally, general appearance and how it looks like is another important thing. These 2 are put into one equation when we figure out the 4 values, or the values of length of curve, or the criteria of these 4 criteria that decides the length of the curve. So the equations are as following. Again, like we did before, we're going to assume first, let me go to number 2 here. So this is for my side distance S, these 2 here. So what happens? Again, you're going to assume a big curve. L is greater than S. And if this happens, this will be the equation. Let me just define the equation for you. A, again, is G1, G2 minus G1, put here between absolute values, that's A. S, we're going to assume is going to be equal to my SSE. 200 again, remember the 200? Once 200, then do this A, put this G1 and G2 to be numbers, not percentages. The H, and H here is the height of the headlights. It's 2 feet if it's AASHTO default, otherwise you can have it a specific value for your specific design. Plus S, S is S, S is D here, 10 beta. Beta here is going to be 1 degree for AASHTO default. It's the angle of the headlight. If I'm going to put here AASHTO default, then the numbers here will turn to be this equation here. Once I finish, I check this assumption. I have now L and S is there. So is L greater than S? If yes, then you're good. If not, I have to move to this one here. And here where it's for a small curve, L is smaller than S. To S, again the 200. H is height of the headlight, beta is 1 degree, A is the difference again, this difference here. If you put H to default, it's going to turn to this equation. And again, it's 3.5s, and the 400 gives you another idea of what value of grade you use. But, and you get here, let's call this L for side distance. L for side distance. This is not enough, because I might get a good value, but still it will not work for drainage. It will not work for comfort. So I have two, we call it empirical equations. Empirical means that it's an equation that doesn't come from a proof, it comes from experience, from actual data. So the first equation here is for comfort. You don't want a bumpy ride. It's equal to A times speed. Well, you have a bumpy ride if you're driving faster, then speed here is something that takes you there, divided by 46.5. So again, AU squared by 46.5, and that gives you L, let's put it here, comfort, LC. Finally, general appearance, another empirical value, that's very easy, just 100, see the 100 here, and A, so it's going to give you L, and it's actually not only works for general appearance, also works for drainage. So here, general appearance. So you have now three values of L, you take the maximum of that three. The maximum of these three, and that will be my L minimum. The minimum length of curve, where it will be serving these three types of criteria. We're going to do another example in a separate video. We're going to do this example, another example for crest curves. And by this, guys, I finish the video. Have a great time, and see you in the next video where we solve a little bit more questions. Thank you so much, and have a great day.